Hola a todos. Esto es lo que pasa con Giancarlo. We've got topic 6, lesson 3, everybody. Determine an appropriate measure of center and variability. I can determine and compare measures of center and variability. The standard is MA.7.DP.1.1. Determine an appropriate measure of center or measure of variation to summarize numerical data represented numerically or graphically, taking into consideration the context and any outliers. Okay, so this lesson talks about median, mean, the like mean is also an average. It also talks about line plots and it talks about range. It talks about interquartile range. It also shows you a stem and leaf plot and a histogram. And for one of the triads, the interquartile range talks about is box plots. So hopefully everybody remembers those. I will try and go over them briefly while going through the problems. Okay. So, example 1, determine an appropriate measure of center. Luis is looking at the data provided by two different vendors at a recent Hispanic festival. He wants to determine the average cost for both vendors to advertise for next year's festival. Should Luis use the mean or the median to describe each data set? Okay, so on this page they have on this slide they have the tables. They've got all the tables, but they would like you to set it up on a line plot. Okay, they set it up on a line plot for you, and here it is. So on for Mexican plates, they've got 1 on 60. That's why there's only one dot over the 60. They had 4 of them equals 70. They had 5 of them that equal $80. They have 3 of them that equals $90. They have 2 of them that equals $100. This is a line plot. Um, I I mean, it's pretty explanatory. You just put a dot over each um over each number that you have. Okay, so we have 1 of them, 4 of them, 5 of them, 3 of them, and 2 of them. So for this kind of data, it clearly says the mean. The mean would be the best situation because I would just add them all up and then divide by the amount of numbers by 15 because um 5, 5, 5. So you add them all up and then you divide it by 15. That is the mean or the average. They're synonyms, mean and average. And then it'll give you pretty much the center of data because it says 80.7 is the mean after you add them all up and divide by 15. You'd get around 80.7, which this is clearly the center of data. Like you can clearly see it's right here. But if we, for the ceramic figurines, mean is adding all up, just in case you guys forget what mean is. All up and dividing by amount of numbers. This is the number sign, also a hashtag, I get it, but it also means numbers. So for the ceramic figurines, if we were to do a mean, this 115 would throw it off. This is what they call an outlier, okay? It doesn't pertain to all the other numbers. It's very far away from it. It would throw off our information. So they say the median would be better for this data because this is just one number. It wouldn't throw us off that much. It looks like it's around here and our median would be 40. Okay. So median is when you put all numbers in order all numbers in order, then find the number in the middle. Okay? So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17, if there's 17, it would be my ninth number because then I would have 8 on the left side and I would have 8 on the right side. So it would be the ninth. Sorry for the pause. I was about to sneeze. Okay. 1, 2, 3, 4, 5, 6, 7, 8. This would be my median. Let me just check. 1, 2, 3, 4, 5, 6, 7, 8. So my median would be 40. That's what this number is because they're going by fives. And it does look like the median. It is more towards the middle than what the mean would be with 115 in there. Okay? That is why they choose the median. That makes more sense for this type of data. For this type of data, the mean is better. It is evenly distributed. Okay? But since we have this outlier, it is skewed data. Skewed means it's leaning towards a different way. This is all pretty even. Look, I can do my little mountain and it's all pretty much there. This is I'd have to go all the way over here. Okay? So that's example 1. Remember what I said that this is a box plot. Okay? Example 2, determine an appropriate measure of variability. The line plot displays the cost of another vendor's pottery at the Hispanic festival. What is an appropriate measure of variability to summarize this data set? So they say the IQR represents the range of the middle 50% of the data, so it is not impacted by an outlier. What is IQR? Well, it is interquartile range. And then you have to think to yourself, what is range? Okay, range is the biggest number minus the smallest number. Okay, well, there's 6 of them, but whatever. It's 90 minus 45. So equals range is the largest number minus the smallest number. Okay, so that'd be 90 minus 45. You would get 45 as the range. Okay, so that is thrown off. Okay, the IQR is interquartile range, which is on our box plot. If everybody remembers a box plot, okay, well, I'm a big bozo, and the line doesn't go all the way through, but I was trying to make it easier for myself, but whatever. This is just a random box plot I made. Okay, so this is least value, greatest value, great value. Not the brand, not the Walmart brand, greatest value. Okay, this would be, of course, the median. So this would be the lower quartile, lower Q quartile, and this would be, of course, the upper quartile. It's hard to write this small. So the interquartile range, IQR, is the upper quartile minus the lower quartile. So IQR equals UQ minus LQ. Literally, everybody should be taking notes. I want every single person taking notes, okay? So this data set has an outlier. This 90 is an outlier because it's not near all of our other points, okay? All of our other dots, all of our other data, info, whatever, is not near 90, okay? So the IQR would be 17.5, you'd split it up between them, is an appropriate summary measure of variability because 90 minus 45 is too big. That doesn't represent it. So the IQR would represent it better because the all of the data is closely together here. Okay, so this 17.5 is the IQR, and that represents the data better than the range of 45. Okay, so interquartile range is you would find the least value, the greatest value, the median, and then in between the least value and the median, you'd find the median again. That would be the lower quartile. And then in between the median and the greatest value, you would find the middle number, and that would be the upper quartile. And then you'd subtract them to find the IQR. Bada bing, bada boom, we're done here. Okay? So moving on to example 3. Example 3, choose center of variability. Adrian tracks the amount of time it takes her to get to school. Adrian's walking data include the fastest time of 15 minutes and the slowest time of 32 minutes. She displays the data in a histogram and stem and leaf plot. If Adrian leaves for school at the same time each morning, would walking or biking be better to get her to school on time? Class. Um, I don't know what kind of person walks faster than they bike because that doesn't make any sense to me. But if they really want to ask us this question, you can see it right here. Okay. This is um they're saying Adrian should choose the range as the measure of variability because it describes variability in minutes for all the data points. So they say 32 minus 15. That would be 17 minutes. Okay. Her her center or her variability would range around 17 minutes. So the the average time of her going to school would be about 17 minutes while walking. So if we did the range for biking, it would only be 3 minutes. Okay, that is not a lot of variability. Okay, that is pretty much the same thing every time. This is like a if you were walking to school, some days you'll walk faster, so you know what time to leave your house. But then some days you'll walk slower or you'll be hurt or you'll walk with a hobble or something like that. So if you left at the same time as before, you would be late. Okay? So when you're riding your bike, it's less variability, so you can leave at the same exact time every single day. Okay? So you can build into your time, hey, I gotta leave 20 minutes early to go to school because sometimes it takes me 13 and a half minutes, sometimes it takes me 16 and a half minutes. Okay? But you have that built-in time. If your first day, if you walk 15 minutes to school, you'll be like, okay, I need to give myself 20 minutes so I have 5 minutes in school and whatnot. So I'm good. But then one day it takes you 32 minutes and you're 12 minutes late, and that's never good. Okay. So they're saying the one with the least variability, which the range would be because the range shows you your greatest value minus your least value, and it shows you really the difference between them. That variability is is not that much when you bike to school, but when you walk to school, there's a huge range of variability. So if you're checking for variability in something like this, you would want to use the range. All right. So let's go back to example one, try it. Luis makes a box plot for a third company at the festival. Should he use the mean or the median to describe the data set? Hmm. Good question. Good question. Good question. Okay, class. What should we use? Should we use the mean or the median? You're right. We should use the median. So we should use the median because the the the, the data, the info is skewed to the right. So the median right here, this the median right in there, is more representative of the actual info. Okay? They don't give us any numbers, but this box plot should do it. It's too far skewed to the right, so the median would give a better option, a better representation. Okay? Let's look at example two. Is the range or the IQR an appropriate measure of variability to summarize this data set? I know you can't see that well. This is 200, 400, 600, 800, 1000, 1200, 1400, 1600, 1800, and 2000. So it is at 1400, the greatest value, and the least value is at 600. Okay? And then that's at 12, that's at 800, this is at 1000. So go ahead, figure it out. We're going to do range and IQR. All right. Okay, now that you've had some time to think after you paused it, what is the range? Well, the range is the greatest value minus the least value. Okay, so that would be 1400 minus 600, and that would be 800. The range is 800. The IQR would be 1200 minus 800, and that would be 400. So what do you guys think is best? You're right, the range. The range would be best. Why? Because there's no outliers. No outliers to skew the data. Okay? If there was an outlier to skew the data, then we would choose IQR. But there's no like huge 2000 or really small 200 to make it look worse. Okay? There's no outliers, so there's no IQR, okay? Right, let's move on. Example 3. Adrian use a measure of center to determine the fastest way to get to school. Go ahead. So look back in example 3, look at the histogram and the stem and leaf plot. Here, I'll show you. Look at the stem and leaf plot and look at the stem and leaf plot and the histogram. Okay? All right, so what do we think? You're right, the medium, the median. The median would be the best way. Adrian can take the median of each data set, the histogram and the stem and leaf plot, and he would determine that riding a bike is faster than walking to school because the median for walking would be 19 to 20 minutes, okay? And then the median for riding a bike would be 15 minutes. So median, because it clearly tells him that walking takes 19 to 20 minutes, and biking takes 15 minutes. All right. So that's the end. Here's the key concepts to help you. If you had any problems, just look over this. Okay. And that is it. That's all she wrote for this video. Lesson topic 6, lesson 3. If you're watching this video, you're a part of the class. See you next lesson, class.